II class, and welcome to 14.2. This is a 2-day lesson. I'm going to make one video. So I'm going to tell you where you can pause and where you could come back to start again tomorrow for the video, or you could just watch the whole video today and try and do both days' lessons in one. I wouldn't mind. We're working on conical sections. Yesterday we looked at the circle. Circle looks like this. And it's a cross-section of a cone. If you were to slice a cone down the side, like if I had a cone here, and if I were to take a slice, not parallel to the bottom or the point of the cone, but kind of coming in an angle like this. So we're just taking a, and we're going to take that cone apart and look at the cross-section that's made. It's going to make a parabola. You could take a cone and you could do that right now. If you sliced right down through the cross section, what you would see where the slice occurs is a parabolic shape. If you made that slice right there. Now we already spent some time working on the parabola this year, so you should be familiar with a lot of what we're going to talk about in this topic. It should sound familiar, but there's some new things, especially amplitude right here. That's going to be new. And how we find that value P and how we graph something called the focus and directrix. Again, you should remember that this H value lies, denoted by the negative sign there, and the K value tells the truth. In a circle, H and K both lie, but in a parabola, H lies while K tells the truth. The parentheses really determine that, and the squared value is what determines how those both lie. And so you're going to probably want a note card, like when you come to the test. I know it's open book, it's going to be open book this year and stuff, but when it comes time for the test, one of the big things that you're going to want to remember is that you should have a note card right there, right available for you, where you have all the different equations, because there's just tiny little idiosyncrasies that change with each one that make a big difference. Now, I talked just a moment ago about focus and the directrix. Like in a circle, you have the radius of the circle is the same all the way through. The focus and directrix do pretty much the same thing, except for they act a little bit differently. And I'll try and highlight the difference in this case. If we were to start with the focus, like I got this green point called the focus, you'll see that it's a point, whereas the directrix is a line. Now, the distance from the focus to any point on the parabola, the distance will always be equal from the focus to any point on the parabola will always be equal to that point perpendicular straight down to the directrix. So what makes it so this works is that this value has to be perpendicular, where the green line does not. It's just a straight line from the focus to that point. And so if you work like that, those values will always be the same. That's why there's one hash from the focus to the point and two hashes from the focus to the second point. And so hopefully that makes sense of what the focus and directrix is. Now, why that's important is there's this new value, this important value called P. P is the distance from the vertex to the focus, and the distance from the vertex to the directrix. But then once you get that point, that single point there, you have a line that isn't parallel to the vertex, but it runs the same direction as the parabola itself. So if it's a parabola that runs left to right, then your directrix will run left to right. Hopefully, as I do some of these problems, this will begin to make sense, and we'll see how this works. Something that's important: focus always inside the parabola. Now, as I'm looking at the next slide, on this particular slide, I noticed that right away that this slide is not, this parabola, the directrix is not going to lie in my graph. So I'm going to have to go off my graph to find my directrix a little bit. But the vertex is HK. So you might say, all right, -3, -5. No, remember, H lies. So because of the lie, instead of -3, it's going to be +3 and -5. So at +3, -5, we have the vertex, right? Now, because this is +1/16, my parabola goes up, and it's very, very wide. Probably even more wide than I made it there. But you just kind of, I don't care. It will take you a long time with plugging values in and setting up a t-chart to graph it if you got every single point right. So all I care about is that you can exaggerate how wide or narrow you think it is, and just as long as you're close, it'll make sense. The key points I'm looking at, especially today, is going to be focus, the vertex, and the directrix. Okay. So then we got to find the focus and the directrix. So we have to find this magical value of p. So the equation I have is the absolute value of a equals 1 over 4p. Well, a is 1/16. Because see here, this is a, which is going to determine where the focus and directrix lie. So we'll say that equals 1 over 4p. I can cross multiply, and 4p equals 16, and p equals 4. P equals 4. So now I'm going to take this value, P equals 4. I'm going to go over to the vertex, and I'm going to go up 1 unit, 2 units, 3 units, 4 units. That's where my focus goes. The reason I know that's where the focus goes, the focus is always inside of the parabola. Remember, my directrix would be down 4 units. And like I said, it's not going to end up there. But if I know the vertex is at -5, if I went down -4, it would be at -9. And it's a straight line that runs across here at y equals -9. So the directrix is y equals -9. And the focus, it's not y equals because it's a point. The directrix is a line, the focus is a point, is at 3, -1. Okay? Let's move on. Some things that are different in this particular problem. I want to highlight a few things that are different. First thing that's different is the a value is negative, and it's not y equals x, it's x equals y. So when x leads, there's something very, very important to note when x leads. This is not a vertical parabola, this is a horizontal parabola. And you'll see what I mean in just a minute when I say that this is a horizontal parabola. So the first thing I want to do is I want to find out where the vertex is. The vertex is the hk value, and h always lies and k tells the truth. So my vertex is going to be at 2, 4, 2, 4, which is right here. That's where my vertex is, 2, 4. And then, because it's x, instead of going like this or like this is when y equals. When it's x equals, troubles there. Fix these things. When it's x equals, it looks like this or like this. This is when x equals a positive. This is when x equals a negative. This is when y equals a positive. And this is when y equals a negative. So my parabola, and it's going to be a little wide one, is going to go back like this. Can you explain to me? I know I'm not listening. If I was in class, I would want to listen. Can you explain to me why the parabola goes to the left instead of going to the right? If you said it's because it's x, it leads with x in the equation and it's negative, that's why it leads to the left instead of leading up like our first one did. and what we're accustomed to. So the next thing we want to do is we want to find the focus and directrix. And that's found by the equation, absolute value of A equals 1 over 4p. So the absolute value of A is 1/2 equals 1 over 4p. I'm going to cross multiply to get 4p equals 2. So p equals 2 over 4. Or you could rewrite that as p equals 1/2 units. So p equals 1/2. Remember, I just go to my vertex. And from the vertex, I'm going to go up 1 unit, and I'm going to put my focus. Now, my focus always is inside of the parabola, so that's how I know that that's the focal point. And my directrix is 1/2 unit down, and it is a vertical line. Because it's a vertical line, my equation is going to be x equals 2 1/2, or another way to write that would be x equals 5 over 4. So my directrix is at x equals 5 over 4. And my focus, oops, where am I? Right there. 5 over 4. And my focus is the point, the coordinate, 1.5 over and 4 up. Or another way to write that would be 3 over 2 and 4. All right, that's how you do that problem. Now, that's day 1. And again, one of the things that I want to do is I want to make your life a little bit simpler. So if I look at this, this is a grand total of 16 questions. 17 questions, excuse me. And so I want to knock that down. Let's make it, numbers 1 to 9. That'll make your life a lot easier. So Algebra 2, 14.2, day 1 is numbers 1 to 9. I'm looking at the book here, and so that'll make it a whole lot easier. Instead of 17 problems, you'll have 9. You can pause the video now, or you could keep going with me. But I'll wait just a minute. I'll take a little pause, and then I'll get into day 2. All right, it's time for day 2. I don't know if you're listening right away or if you went and did your homework and you're coming back now. But either way, we're going to keep going. So here in this problem, we're given the vertex. So I'm going to start by plotting the vertex. That's going to be very, very important for you to do, is to make a graph of what we're looking at. Okay. Then it says the directrix is at 2. So I could say, all right, get my highlighter out here. Let's make a green line for the directrix at y equals 2. So it looks just like that. So I got my vertex, which is the point, and my directrix, which is at y equals 2. The question I'm going to ask is, could we find the focus? Well, let's just say this. Could we find P? Let's see if we could get out our pen here and say, we got 1 unit, 2 units, 3 units to the vertex. So P equals 3. So couldn't we go 1 unit, 2 units, 3 units to find the focus? So I'd say that that's probably going to be at the point 4, -4. Does that make sense? Now if we're going to graph it, remember the focus is always inside of the parabola. But maybe even before that, couldn't we find A, the absolute value of A? How I'm going to do that is going to say it's 1 over 4p. Do you remember what p was? You're right. P was 3. We calculate that because we could count 3 units down to that. So A equals 1/12. So question is A positive or negative? Because remember, it's the absolute value. The focus is always inside of the parabola. So wouldn't it look like this, my parabola? It's wide. and it goes down. So wouldn't a be negative because my parabola goes down? Absolutely. So because it's a vertical parabola, it's going to be y equals negative 1/12. I just showed you how to get a. Now we're going to put it into the equation. And the equation always has a set of parentheses and it's squared. And there's an x in there. And now, do you remember how I get the last values? Well, absolutely. It's because of the vertex. So it's going to be negative 4, because h always lies, minus 1. That's how I get the equation. Hopefully that makes sense to you. Let's keep moving on. All right? Let's do this problem now. I know the vertex is at negative 1, positive 5. That's the vertex. And as long as I'm careful, I think you guys will do just fine at this. Now the focus is at positive 1, 5. So right there. So the focus. So can I now like pretty much graph this parabola? Wouldn't the parabola probably go like that? It's a little bit different from the last one. Like look back at that one. Oh, that one went down. This one goes to the right. Remember what I told you about that yesterday? I think that that's going to make it be x equals something. And so what I really would like to do now is I'd like to find the equation of the directrix. The value, if I go back here, we go 1, 2 for p. So we could also go back 1, 2 for p to find the directrix. The directrix is a vertical line. The last one was horizontal because y led. This one is vertical line. So this one's going to be the equation x equals negative 3. You can see it passes right there through negative 3. I have radius here. That's for a circle. Did my last slide? No, my last slide didn't include radius. It must have been just when I was copying the little graphs and everything, I kept the value radius. So there I have it graphed, and I have the focus and the directrix. But if I want to get the equation, I need a. So the absolute value of a is found by 1 over 4 times p. Now what is p? We already determined p equals 2. So that's going to be 2. So the absolute value of a equals 1/8. Now the next thing we determined was, last time was, is a positive or negative? Last time a was negative because it went down. This one's going to the right. So is that parabola heading in the positive direction or the negative direction? Well, physics students, you should really know that that is heading in the positive direction, to the right. And again, that's just kind of an orientation, but that's very, very, very important. It helps establish the direction. So it's positive 1/8 times x plus, and we're going to go to the vertex. This one, they're very close, so don't get confused. H lies and K tells the truth. That's not too bad, is it? I hope you're getting this stuff. Let's move forward. Oh boy, oh boy, oh boy. This one's a little bit trickier because, as you'll see, it's not in graphing form, so we have to put it into graphing form. How we're going to do that is through a process called completing the square. Oh, here, guys, here, my little girl Miley. I'm going to say hi. Can you say hi, Miley? Hi. There you go. So, but anyways, let's keep going. We're going to complete the square in order to find the solution, to put things in graphing form. So if you remember how to complete the square, you isolate the x's, you take the b value, which is 6, you divide by 2, and you square it. Now, before we square it, we're going to star it. So we get 3, and we're going to star it, and then square it, and we get 9. So then what we do is we take that 9, so we get y equals x squared plus 6x plus 9. And if I add 9 on one side of the equation, I'm actually supposed to add 9 to the other side of the equation. But actually what we're going to do is we're going to just subtract 9 outside of the parentheses. Because if you think about it, if we added 9 and we subtracted 9 to the same side of the equation, we actually did nothing. So our net change on the equation is 0. But what that allows us to do is to complete the square. Now watch what happens when we perform a CTS. With a CTS, we put our squared value, and then we put x plus 3. There's 2 ways I know that it's 3. X plus 3 times x plus 3 is x squared plus 6x plus 9, if I FOILed that all out. Or the other way, I started just a minute ago, and that's why I usually start before I square it, so that I know what my value within the parentheses are going to be. And I combine like terms out here, I get negative 2. That's really nice because that gives me the vertex. The vertex is going to be negative 3, negative 2. That's where my vertex is. Negative 3, negative 2. And now if that's my vertex, and this is the equation here, my A value is equal to positive 1 because there's nothing out in front of there. So that means it's going to be a normal parabola that heads up like that. Looks just like that. Now we have to find the focus and the directrix. How I do that is I take the absolute value of A equals 1 over 4p. So if A is 1 equals 1 over 4p, cross multiply 4p equals 1, p equals 1/4. When that's a kind of a normal p value. So that means I go up 1/4. And that's where my focus is. And I go down 1/4. And that's where my directrix is. So my focus is at the point negative 3 and negative 1 3/4. You got to be careful when you're looking for that. And the equation of the directrix is y equals negative 2 1/4. Let me know. Give me an email or call me or let me know on LMS if you're having any questions with this. I'll be happy to help you. So that's 14.2, day 2. And so as I look at this one, let's see, there's 4 questions plus 2 questions plus 4, 5, 6 questions. So 2, 4, 6, 4 is 14 questions. So let's knock that down to about 7. Let's do 13 and 14. And let's do 21 and 22. And let's do 27 to 29. Okay? So that'll be our homework for this lesson.